Today's lesson is the final lesson on reciprocal trig functions, and we're going to be solving equations. Here's your starter. You should see the similarities between them, and it's good practice. Here are the solutions. Okay, see if you can spot which of these is a trig identity from what we did yesterday. Well done if you got it right, because they all look very similar. The other ones will either only be true for certain values or will never be true. In this lesson we're going to be solving trig equations. We might need to use the identities you've learnt about when we're given a complicated equation, but we're going to start off with some straightforward ones. So here's our first worked example. For the first example, we see that we're working in radians. The trig function is not the subject at the minute, so we need to divide through by 2 to make sure it's on its own before we start. Your calculator doesn't have a cut button, so we take the reciprocal. We're now in a position to use inverse tan on the calculator, so shift tan of 2/5 gives us 0.381 radians. Okay, now we look at the range of values, so we need all solutions in this range, so I'm going to start with a cast diagram. And I know that tan is positive, so I'm going to select those quadrants. There we go. And draw my angles in there. They're always made with the x-axis. Now we know that we're going from negative pi round to positive pi. So I need to find this negative angle and that positive angle. So we've already got the positive angle. To get this negative one, we do negative pi plus our 0.381. So we'll add negative pi, and that gives us negative 2.76. Okay. Right, you might be a graph person, so I will just draw a little tan graph. Okay. Okay. Then we need to look at where it intersects 2/5, y equals 2/5. So I'm just sketching on a 2/5. We can see that we're intersecting here and here. Okay, now we know that this is 0.381, so we know that this width by symmetry is the same as that width, so we can do negative pi plus 0.381. Now, if the question didn't say determine or show detailed reasoning, then we can use the calculator to work out our answers. So we've got 2 ways to do it. If we are in run mode, we're going to go options, calc, and then solve n. Now we type in the equation, so the equation is 2, and then cot is 1 over tan, so I'm doing 2 over tan x. Okay, then we do shift decimal point to give us equals, and then we want 5. Comma, what's the variable called? We've called it x. And what's our range of values? Negative pi, and our maximum value is pi. And then we execute and wait for a moment. Okay, it always says this, there may be more solutions, but we do exit. Okay, and there we go, we've got negative 2.76 and 0.381. So that's good reassurance. The other way to do it is to go to the graph mode. I'm going to type in the graph of 2 cot x, so yet again we have to do 2 over tan x, okay, and the graph of y equals 5, and we want to see where these intersect. So I'm going to go to my view window at the moment to make sure that I'm in a trig format, and that should hopefully be okay. I know my y's have to go past 5, so I'm going to change my y maximum. Instead of being 5, let's have, I don't know, 7. Okay, right, let's see what that looks like. Okay, it's a little confusing. Again, I'm going to change my x min and max to go from -pi up to pi. So I'm using the range of values that we need. Okay, so now we can see that the graphs intersect, so I'm going to use gsolve and intersect ISCT. Okay, and we're told that the first answer is -2.76, which is super, and we press the arrow to get the next one is 0.381. Here's the second example. For the second example, we're now working in degrees, so I'm going to change my calculator to be working in degrees before I start so I don't mess up. We have got the trig function on its own, so we can go straight for finding the reciprocal because we don't have a sec button. So cos theta is going to be 1 over -1.9, and then I can do inverse cos. Okay, that gives me 121.8 degrees. I then look at my range of values and I draw my cast diagram. Okay, this time cos is negative, so we're looking at where cos is negative. It's positive here and here, so it must be negative in these two quadrants. We draw our angle A. Now the angle is always made with the x-axis. Our angle is 121.8. So this one will also be 121.8. Okay. We need to have all angles from 0 round to 360. So we've got our first angle we've already got, and the second angle we're going to go past the 180 mark. We could do 360, take away 121. And that gives us 238.2. Okay, now if you prefer to see a graph, this time we would like the cos graph. Okay, and we're going from 0 up to 360. We are crossing y is a negative value, so let's draw that on. So this is going to be -1 over 1.9. We can see our points of intersection are here and here, and we know that this distance is 121.8, so that means by symmetry this distance is also 121.8, so we do 360 minus 121.8. On your calculator, if you weren't asked to show detailed reasoning, in run mode it's options, calc, and then solve n. Then we type in the equation. So sec we don't have a button for, so we're going to put the reciprocal of cos x, and shift decimal point will give us equals -1.9. Then we put a comma, then we tell it what the variable letter is, and then we put our range of values, so it's 0 up to 360, and execute and wait a little bit. Goodbye warning, and we get 121.8 and 238.2. Alternatively, if you go to the graph menu, we can draw a graph of 1 over cos x, which is sec, okay, and a graph of -1.9. I'm going to look at my view window. I'm going to press trig because now we're in degrees. Need to change over. We want to go from 0 up to 360, okay, and hopefully our y values are okay. Let's see what happens. Oh no, hang on. On the y values we need to make sure that we're going down below negative 1.9. So let's do negative 2.5. There, now we can see our intersections, and we do G-solve intersection, and we get 121.8, and then the next one is 238.2. And here's the third example. In this third example, we're in degrees again, and notice this time our input, our angle, is 3 theta, not just theta. So we need to change our range of values to be for 3 theta instead. Okay, right. On the PowerPoint there's a link to explain why we do this and why we don't divide by 3 until the very end. Okay, so now we have the trig function on its own. It's a reciprocal trig function, so let's take the reciprocal. Okay, and it's just the same as before. So if we do inverse cos of that, we got 121.8. Okay, we now need to find every value for 3 theta in the range 0 to 1080. So I'm going to draw my cast diagram for that. And again, we're looking where cos is a negative value. So cos is positive, C and all. So we want these two. We draw in where our angles are. Okay, so this is 121.8 degrees. So that will also be, making with the x-axis, 121.8 degrees. Now we're starting from 0 and we're going to whirl round 3 times to get to 1080. So I'm going to write out all my values. So 121.8 is where we start. The next one we do 360 minus 121.8. So I'll just draw that one on. Okay, and that gave us from before 238.2. Okay, so then basically we're just going round again, so we need to add 360 onto the 121.8. 360 plus 121.8 is 481.8, 198.2, 841.8, 0.2 degrees. Okay, so we've got all of the angles for 3 theta in the range up to 1080, and if we divide everything by 3, we'll get all the values that we want in our range 0 to 360. So let's just divide the last one. So that one will be 319 degrees, and I'll just do to 3 sig figs. So 841.8 divided by 3. It's a bit tedious this, so what we're going to do is use our calculators to get all of the values for the rest of them. So rather than having to work them all out individually, I'm now going to use the solve n button. So options, calc, solve n, and the equation is 1 over cos of 3x, okay, and that is equal to negative 1.9. Our value is x, and the range for x is 0 up to 360. And let's see what we get. Okay, so the first one is about 1/3 of 121. Okay, and then we've got 79.4. And I just go up and read them along. So then 160. 1, we'll round it to 199.4, so that'll just be 199, and then we should hopefully be on, yes, 280. Okay, so those are our answers. We can also check using the graph, so let's go into graph mode. So I'm going to do 1 over cos of 3x, okay, and negative 1.9. So y equals the left and y equals the right. Let's just check the view window. I'd like to go from 0 up to 360, okay, and I need to make sure I'm including my negative 1.9, so let's do negative 2.5. Okay, and draw the graph. We know that it's a stretch of sec in the x direction, scale factor a third, so we've squashed up the sec graph, which makes sense. We do g-solve and we do intersect, and there we go. We can step ourselves through our 6 different solutions. Here are some questions for you to try. It would be a good idea, they follow a pattern, so it's a good idea to kind of think about the previous one you've done and see if you can predict what might happen in the next one, and then check your answer by working it out. And if you get a surprise, see if you can understand why, or if it's something you predicted, can you explain that connection? Here are the answers. So now we're going to look at more complicated equations. You can recall some of your techniques from your AS Maths. So you can see that this one is a hidden quadratic, and that should help you answer this question. Here's the answer. Okay. This one here hasn't got any squares, and we've got different functions, trig functions there. So I would use an identity that makes you have sines and coses. Here's the answer. And on the last one, there's a nice little way of rearranging this. That's your answer. So now we do the same sort of thing, but with reciprocal trig functions as well, and the reciprocal trig identities you have met in the previous session. Here's example 4. In this example, we're working in radians again, so I need to make sure my calculator's in radians. Then we look at the equation, and we can see we've got 2 different functions of trig functions. So I'm going to put them all in terms of sine and cos, because there's no identity leaping out at me. Okay, but I will go straight for the identity for cot that we learned, which is cos theta over sine theta. And now, because we're not doing an identity, we're doing an equation, I can multiply both sides by sine theta and not have any fractions. Lovely. Then if we look here, we've got a common factor of cos theta, so let's factorise. So we know that each of these can equal 0. So solving cos theta equals 0 in this range, I can just think about my cos graph. Okay, then cos theta is 0 at minus pi over 2 and plus pi over 2. For this one, we have sine theta is negative a fifth, so I'm going to use my calculator to work that one out, and I get theta is negative 0.201 radians. I need to find all my solutions in this range. So I'm going to draw a cast diagram to help me. The sections that I need to look at are the ones where sine is negative. So sine is positive in all and S. So I want these 2 regions. So I'm going to draw my stick in there, my angle. Okay, and I know that angle is 0.201. Then I think about the range of values. So I'm going from minus pi all the way around to positive pi. So clockwise for negative, anti-clockwise for positive. which means I need this angle here because I've already got that one there. So to get that, I'm going to do my answer from before plus pi. Or I could do negative pi plus 0.201. And that gives me 2.94 radians. If you prefer a graph, then you would sketch your graph for sine. Okay, and the graph for sine between minus pi and pi looks like this. We can draw in our line for negative a fifth, obviously very inaccurately. And our points of intersection are going to be here. And here we know that this distance between 0 and the first intersection is going to be negative 0.201. So by symmetry, we can work out the other intersection by doing negative pi plus 0.201. Okay, remember on your calculator to check, you press options and then calc and then solve n, and we type in the equation. So 5 cos x plus cot is 1 over tan x equals 0. And our variable is called x. We're going from negative pi to pi. And let's see what the calculator gives us, hopefully 4 answers. We get negative 2.94, excellent. And then we've got negative 0.201. Great. Now it hasn't given us the other 2 solutions. Okay, but if you wanted to double check, you could substitute pi over 2 in there and you should get the correct answer. Let's have a look on the graph. So we're going to draw the graph of 5 cos x plus cot, so 1 over tan x. Okay, and so we're going to be looking at where it crosses the x-axis. I'm going to make sure that my view window, I've better press trig again so I get radians, and I need to definitely go from negative pi to pi, so negative pi to pi. Let's see what happens. Oh my giddy aunt, a bit of a mess, but we just want the roots. So if we do g solve, root negative 2.94, and then we've also got negative 0.201, and the one it's not showing us, although the graph shows us. Okay, if you look here, the graph is crossing here and here as well. So that will be our negative pi over 2 and pi over 2 values, right in the middle of the range from 0 to pi. This one's the 5th example. For this example, we're working in radians again. So my calculator is in radians. Then we look at the equation and we can see we've got a mixture of different functions, but crucially, we have got a squared function. So we're thinking Pythagorean identities. The one that we will want is cot squared x plus 1 is equivalent to cosec squared x. What we're aiming for is a quadratic in the function that doesn't have a squared in it. So we're going to replace the cosec squared and write it in terms of cot. So the left hand side is cot squared x plus 1. The right hand side hasn't changed. This is now a hidden quadratic. I'm going to write it so that it's equal to 0. And then I can use my calculator to work out the different values of cot. So putting in the coefficients, we've got 1, -3, -4, and that gives us cot x is equal to 4, or cot x is equal to -1. We can't do inverse cot on the calculator, so we need to take the reciprocal. So tan x is 1/4, or tan x is -1. If tan x is 1/4, let's see what we get. Shift tan of 1/4. We get x is 0.245 radians. We need to find all the values of x in the given range, 0 to 2 pi. I will draw a cast diagram to help me. I know that tan is positive here, and tan is positive in the all and the t quadrants. That's where we draw our angles. We know that this one is 0.245, so the angle made with the x-axis over here is also 0.245. Let me just move that so you can actually see the cast diagram. There we are. And then we go from 0 anti-clockwise to 2 pi. So we've already got the first angle. The second one, if we do pi plus 0.245, that will give us our value, which is 3.39. And that's all of them up to 2 pi. Let's look at the next one. And know that because there's a 1 in it, we should be related to pi over 4. So if we do inverse tan of -1, we get -pi over 4. Now that's not in our range. Again, I'm going to use a cast diagram. This time I want the regions where tan is negative. So the opposite pair, so not the orange ones. Let's have a different colour. These two blue ones. That's where tan will be negative. We draw our line in, and we always make the angle with the x-axis, and it's pi over 4. So going around our range of values from 0 up to 2 pi, we get two different angles there. The first one, these add up to pi, so that's going to be x is 3 pi over 4, and this one we could do 2 pi, take away 1/4 pi, which gives us 7 pi over 4. So those are our solutions. Let's just check we've got it right on the calculator. We press options and then calc, and then solve n, and we put in our original equation. To put in cos x squared x, we're going to have to put 1 over sine x all in brackets and then square it. So we start with brackets, 1 over sine x, and then end bracket squared, and that is equal to 5 plus 3, and cot, remember, is 1 over tan. Then we tell it that the variable is x, and the range of values is 0 to 2 pi. We get our 0.245, we get 3/4 pi, we get 3.39, and we get 7/4 pi. Excellent. This one is the final example. Notice here we've got 2x rather than just x. On this final example, we're working in degrees, so we check on the calculator that we're working. On this final example, we're working in degrees, so we check on the calculator that we're working in degrees, which we are. Then looking at the equation, we can see that the angle, the input, is 2x rather than x. So firstly, I'm going to change the range of values to be for 2x rather than x. Okay, and now looking at the equation again, we can see we have a squared term, so we're thinking about the Pythagorean identities. So the one we need is the one with tan in it, and that will be, if you look it up or work it out, tan squared theta plus 1 is equivalent to sec squared theta. Okay, now this is good news because we've got a denominator of cos here which is equivalent to sec. So we're going to replace the tan squared in terms of sec squared, and we're going to replace the cos in terms of sec. Using brackets to make sure we don't make a mistake with the 2, we're going to need sec squared 2x minus 1 in the brackets, and then we've got plus 3, and this is the same as sec of 2x, and that will equal 0. So we have a hidden quadratic. Let's expand it out and tidy it up. And then we can use the calculator to solve the quadratic. So let's go polynomial solver and put in the coefficients of 2, 3 and negative 2. And we get sec of 2x is equal to a half, or sec of 2x is equal to negative 2. We can't do inverse sec on our calculator, so we need to take the reciprocal. So we now have cos of 2x is equal to 2. Hopefully some alarm bells are ringing there, because we know that cos is between negative 1 and 1. So this is going to give us no solutions. So we say that, we say no solutions, and we give a reason. Right, so we turn our attention to the other one. So we've got cos of 2x. It's going to be the reciprocal of negative 2, so negative a half. And let's inverse cos that on the calculator. It's 120 degrees. So we want to have all of the solutions in the range negative 360 to 360 for 2x. To help me work that out, I'm going to do a class diagram. We know that cos is negative. Cos is positive in here and here, so we choose these two quadrants instead. We draw our angle in. We know this makes 120 degrees, and so it will be exactly the same on the other side. And then we're going to go around from negative 360 to 360. So clockwise is the negative direction. That means we're going to need this angle here and this angle there, and going the other way in the positive direction, anti-clockwise, we're going that way, and we need this one right round here. Okay, so to get this one, I know that 360 take away 120 is going to be 240. So we have 2x is positive or negative 240 and positive or negative 120. And finally we can halve everything. Let's double check we've got it right. This time I'm going to use the graph mode. So let's draw in the left hand side of the equation. So we have 2 tan squared, so we need to put the tan in brackets. So tan of 2x and the brackets and then squared, and then plus 3 over, and it's cos of 2x, so cos brackets 2x. Okay, it equals 0, so we can just look at the roots. Let's just check the view window is sensible. We are going from, our range of values for x are negative 180 up to 180. See what happens. Okay, we can't really see the graph, but we can see that it crosses the x-axis in 4 places. If we do g-solve and then root, we get negative 120, negative 60, and then positive 60 and positive 120. so we're right. Here are some practice questions for you to do. These ones aren't connected to each other, there's a good mix. And here are the solutions. Now this is an exam question. It's quite challenging, but similar to one of the examples you've done. Here are the mark schemes. And finally, this one's quite a tricky question to solve. If you'd like to solve it, there are details on the PowerPoint, or this is the answer you should be getting. Well done.